Ever wondered how the internet reaches your home? Today we will unravel the mystery. The internet, in its vastness, is delivered right to your doorstep through an intricate web of physical components. This is where the physical layer of the internet comes into play. It's the foundation of the internet structure. This layer is responsible for the transfer of digital data from one device to another. It's the real hero behind the scenes, ensuring that your cat videos load without a hitch. So what makes up this physical layer? Two main things: networking cables and network devices. Networking cables, like coaxial, fiber optic, and twisted pair cables, act as the highways for your data. Network devices, such as hubs and repeaters, help manage this data traffic, ensuring it reaches its destination efficiently and accurately. Are you ready to dive into the world of networking cables? Let's go! Imagine the internet as a series of tubes. The networking cables are these tubes. Now, these tubes, or networking cables, come in three main types: coaxial, fiber optic, and twisted pair. Each type has its own set of advantages, disadvantages, and typical use cases, and we're going to explore each one. Let's start with coaxial cables. These are the oldest type, and you might recognize them as the thick cables that connect your TV to the cable box. Coaxial cables have a single copper conductor at their center, shielded by a layer of insulation and then a metal shield, which helps prevent interference. They're robust and reliable, but they're also bulky, and their data carrying capacity isn't as high as other types. Next, we have fiber optic cables. These are the high-tech, high-speed option. Instead of using copper, they use thin strands of glass or plastic to transmit data as pulses of light. The result? Incredible speeds and the ability to carry data over long distances without loss. But they're also more delicate and expensive to install and maintain, which makes them less suitable for some applications. Last, but certainly not least, we have twisted pair cables. These are the most common type of networking cable you'll see today, especially in Ethernet networks. They consist of pairs of copper wires twisted together, which helps to reduce electromagnetic interference. They're more flexible and cheaper than coaxial or fiber optic cables, but they also have a lower capacity and range. So how do you choose the right cable? Well, it depends on your needs. If you're setting up a small office network, twisted pair cables might be your best bet. For a large data center, fiber optic cables would be the way to go. And for a home cable TV setup, coaxial cables are still king. Now that we understand networking cables, it's time to move on to network devices. Now, let's talk about the traffic controllers of these internet tubes. Network devices. Picture this: a bustling city with traffic flowing smoothly. This is possible because of the traffic lights and signals that control the flow of vehicles. In the world of networking, the equivalent of these traffic controllers are the network devices. Amongst these, two fundamental devices are hubs and repeaters. First up, hubs. These are the simplest of network devices, often used to connect multiple Ethernet devices together, making them act as a single network segment. Think of a hub as a grand central station, where data packets arrive and are sent out to all connected devices. But remember, a hub doesn't discriminate. It sends all data to all devices, whether relevant or not. This makes hubs less efficient for large networks, but they can be quite useful for small home networks. Next on the list, repeaters. These devices serve a simple yet critical function. They regenerate and retransmit signals they receive. Imagine a runner in a relay race, passing the baton to the next runner. That's what a repeater does with network signals. It takes weak signals, strengthens them, and sends them further down the line. This extends the reach of the network beyond what a single cable could accomplish. Repeaters play a crucial role in long-distance data transmission, ensuring that your cat videos and work emails reach you without any hiccups. So, why are these devices important? Well, without hubs, your devices would struggle to communicate with each other. And without repeaters, the reach of your network would be severely limited. These devices work behind the scenes to ensure smooth and efficient data transmission. Just as a city needs traffic controllers to manage the flow of vehicles, your internet needs network devices to manage the flow of data. And while hubs and repeaters may not be the most glamorous parts of your network, they are certainly amongst the most important. And that's how the internet reaches your home, through a complex yet fascinating system of cables and devices. Let's take a moment to recap what we've learned. We delved into networking cables like coaxial, fiber optic, and twisted pair, and explored the roles of hubs and repeaters in the internet's physical layer. Now, the next time you use the internet, you'll have a better understanding of the complex network that makes it all possible.